Hey guys, today we're going to continue looking at limits, and today we're looking at limits at infinity and infinite limits. And in order for us to determine those values, we are going to use asymptotes, which we covered in the rationals unit a while ago. So let's look at some examples. So if I'm looking at a limit that looks like this guy, where I have this picture and it's asking me what's happening as x is going to infinity. And we've actually seen this before. Limits at infinity is really just asking you about the end behavior of the graph. And if you remember, in order to find end behavior, we look at those horizontal asymptotes. We decide what number is this graph trying to approach but is not ever going to reach. So if I'm looking at this, we've seen this notation before. We just said as x goes to infinity. Now we're going to put it like this. So we're looking at what the y is doing as x is going to positive infinity. And if I look at my graph, this branch is getting closer and closer and closer to that number right here, which is 1. And so as my graph goes to infinity, my x goes to infinity, my graph is going to 1. Similarly, if I'm going backwards, my graph is actually doing the same exact thing, because that end behavior, both sides are trying to approach that number, which is 1. So this guy has a horizontal asymptote at y equals 1, and so that's what the limit is as x goes to infinity on either side. So if I look at something that doesn't have a picture on it, so if I'm just looking at an equation, you're going to have to remember how to find a horizontal asymptote. And in order for us to do that, we're going to use the degree of the top over the degree of the bottom. And the degree is just the highest exponent. So if I looked at this example, I would only have a 1 up here. And so if I look here, the degree of the top is 1, the degree of the bottom is 1, and so that's same over same. And when you have same over same, remember we said that was name. And you take the coefficient of the top over the coefficient of the bottom. And so for this guy, the coefficient of this guy was 1 over 2, and so my horizontal asymptote there would have been 1/2. So as my graph approaches infinity, my y value is also going to approach 1/2. And that's going to be the same from either side, because if you think about it, that's the end behavior of the graph. Both sides are trying to get really, really close to that number. So as it goes to positive infinity or negative infinity, you're going to have the same number. It's your horizontal asymptote. Okay? If you had an instance where your degree was high over low, remember that has no horizontal asymptote. It might have a slant. And low over high, we had 0 equals y. So that means that limit would be 0. So let's look at a couple more examples. This one right here, we have the limit as x goes to negative infinity of this rational function. And if I look here, my degree of my top is 2. The degree of my bottom is also 2, because I look for the biggest exponent. Not necessarily the first, but the biggest. So now if I try to do this, this is same over same, which means I need to find the coefficient of the first one over the coefficient of the bottom one. Now be careful there, that is a negative. So my horizontal asymptote there would be 5 over negative 2, or negative 5 over 2, or possibly negative 2.5. So that would be your limit from either direction in infinity, negative 5 over 2. Now if I look at one like this, where the bottom is factored, that would make it really nice to find a vertical asymptote. However, I care about the degree of the bottom. The degree of the top is pretty straightforward. It's just 1, because there's only one x up there. But I would have to think about this one if I FOILed this out. So if I FOILed the bottom out, that would have left me with x squared as my highest exponent. So that means the degree of the top is, the degree of the bottom is 2, which means that this is a low, a 1 over a high, 2. So low over high, 0 equals y, which means that the asymptote here is just at 0. And so again, if it was negative infinity or positive infinity, we would still put the same number. So basically, if you have an infinite limit, you're going towards an infinity or negative infinity, you're just looking at horizontal asymptotes. So what if they give you some crazy thing like this? They want you to find the horizontal asymptote of 7x over the square root of x squared plus 4. Well, again, I'm going to be looking for the degree of the top over the degree of the bottom. So the degree of the top is just 1. If I wanted to figure out what the degree of the bottom is, though, the highest exponent in there is the square root of x squared, which if you took the square root of x squared, that would just be degree 1, because the square root of x squared is just x to the first. So basically this is going to be a same over same situation again because I have a 1 over a 1. But you have to be really, really careful here. The coefficient of the top is 7. Okay, but the coefficient of the bottom is this number, which is just 1, but it's the square root of that number. And when I take the square root of a number, I have to remember to do plus or minus that square root. So I have to do plus or minus 1. So all of my horizontal asymptotes for this guy would just be plus or minus 7 divided by 1, which is just plus or minus 7. So I'd have a horizontal asymptote at positive 7 and a horizontal asymptote at negative 7. Okay, so that's limits at infinity. If you're looking for horizontal asymptotes, that will help you find anything that goes to infinity. Now, if you have an infinite limit, where we're looking at something that has that vertical asymptote. So basically right here, what you're going to be looking at is just the sides. What's happening from the right side and from the left side. So if I'm looking at this graph is just actually my rational parent function shifted over to. And so I know I have that that vertical asymptote at x equals 2. And normally that's an unbounded limit, so I couldn't do anything there. However, I can look at either side and say what the graph is approaching as I'm coming from the right side or as I'm coming from the left side. So if I look here, remember if you have a little plus sign up there, that means I'm coming from the right side. And if I'm looking at that branch is going up and up and up and up and up, and it's getting closer to positive infinity. So I have that right side limit is positive infinity. Now if I'm coming from the left side and I'm looking, this one is getting smaller and smaller and smaller and smaller and smaller, which means that I'm approaching negative infinity. So I can have a one-sided limit on these guys. However, if I look, the right side doesn't equal the left side. My graph is actually unbounded here because it's just going forever and ever and ever, which means that the limit of that whole number does not exist. There's a vertical asymptote there. However, I can find from one side, and it's just an infinity or a negative infinity. So if you see something at an asymptote, you have a 50-50 chance of getting it right. It's either positive infinity or negative infinity. Okay, so if I'm looking at a function, again, an infinite limit is dealing with vertical asymptotes. And so you could draw a picture of these if you really wanted to, but there's also another way you can do this. So I'm looking right here as I'm coming in from the right side. That's what that plus means again. So what I'm trying to look for, if I plugged in 0 on here, I get 1 over 0. So we know that that's an asymptote, which means the whole limit does not exist at 0. However, if I'm just looking for the plus limit right there, I know that that branch is approaching something. So what I'm going to do is I'm going to think of a number that's to the right of 0, that's really close to 0 but not quite 0. So I'm going to try 0.1. That one's to the right side of 0 if I drew a number line, and it's pretty close to 0. I'm going to plug this into this limit, and I'm going to see that I have 1 divided by 0.1. Now, I don't really care about what the value of that is. What I really care about is the sign. I have a positive number over a positive number, which means that I'm going in general, I'm getting bigger and bigger and bigger that direction, which means the limit as x goes to 0 from the right side of this guy is positive infinity. So I'm looking at a number that's around the number that they gave me, the number that I'm trying to approach, and I'm going to think, am I coming from the right or the left? So similarly, if I'm coming in from the left side with the negative, I'm going to try a number that's to the left of that guy, so negative 0.1. Okay, and if I plug that in, I get 1 over negative 0.1, which gets me a positive number over a negative number, so overall that fraction would be negative, which means that my graph is approaching negative infinity. And if I drew my parent function, that rational parent function, I would see that was true. As I'm coming in from the right side at 0, I'm going up and up and up, getting closer to infinity. And as I'm going from the left side, I'm going lower and lower and lower, so I'm getting closer to negative infinity. So again, you're thinking of a number that's around the number they gave you in your limit, and you're just going to plug in something close to it and look at the signs. It's like the sign charts we did with quadratics and polynomials. So if I look at something like this guy, again, my first choice is always to try to plug in my number and see what happens. If I plug in 2 in here, I get negative 3 over 0, which tells me I have a vertical asymptote, which means I can't just calculate my limit there. If I look, the negative is the left side, So I want to think of a number that's to the left of 2 that's pretty close to 2. That number would be something like 1.9. I'm going to go ahead and plug it in to this fraction. So negative 3 over 1.9 minus 2. And again, I'm worried about the signs here. That my top is, my numerator is negative. My bottom, if I have 1.9 minus 2, that would be a negative as well. So a negative divided by a negative would get me a positive, which means on the left side of this asymptote, I would be approaching positive infinity. And that would make sense. This negative just reflected my graph, and so if I graphed it, that's what I would be looking at. So again, just trying to plug in a number. That's really what's happening here. Looking at my vertical asymptote, finding a number that's around it. So if this last example down here, again, if I plug in 5, I find that I get negative 4 over 0 squared, or 0, so this is a vertical asymptote. It's going from a negative direction to the left side, so I think of a number that's to the left of 5. So a number to the left of 5 would be like 4.9. Try to plug it in. So I have negative 4 over 4.9 minus 5, quantity squared. Be careful there. This is all squared. So I'd have a negative on top divided by a negative number squared, which a negative times a negative is a positive. So I really have a negative over a positive, which then means that I have a total negative expression, so my function is approaching negative infinity. So that's all you got to do if you have an infinite limit. So if you're looking at a vertical asymptote and you're trying to determine where that branch is going from the left or the right side, just plug in a number that's close to the number that's either on the right or the left and determine, is the sign going to be positive or negative, and that's, just put that sign in front of infinity. Again, you got a 50-50 chance of getting those questions right. So if you're looking at something that has a limit as x goes to infinity, that's a horizontal asymptote. That's an in behavior issue. If you're looking at an asymptote, a vertical asymptote, that's when you get to just plug in a number. And I will see you tomorrow.